Welcome to Math with Malia. Today we're doing Savvas enVision Algebra 1, Topic 7, Lesson 1, Adding and Subtracting Polynomials. After this lesson, you'll be able to combine like terms to simplify polynomials. We've got some new vocabulary we're going to learn, and this, in my opinion, is one of the most fun things to do in algebra. For the exploring reason, we have this diagram of food donations at a food drive. And we're going to write some expressions to represent how much food was collected. So you can see we've got 3 bags of oatmeal, 6 cans of peas, 3 cans of meat, 5 cans of beans, 6 cans of corn, and 4 bags of rice. And the bags appear to be about the same size. The cans appear to be about the same size as well. So we want to describe 2 different ways that we can sort them. We can sort them by total ounces, like we can sort them by bags and cans. So we could just count how many total cans there were and then how many total bags there were. We could also sort them by type of item. So how many oatmeals were donated, how many peas, how many meat, etc. So let's write 2 expressions to represent those 2 different situations. If we're just counting bags and total cans, so we'll say B represents the number of bags. How many total bags do we have? We have 7 bags. And then how many total cans do we have? Well, we had 6, and 6 is 12, 13, 14, 15, plus 5 more is 20. So that would be just the total number of items. If we want to specify the types, then we could say O for oatmeal. So we have 3, I'm going to say, well, O, that's an O for oatmeal, plus how many peas do we have? We have 6 cans of peas, plus we have 3 cans of M for meat, plus we have 5 cans of B for beans, and we have 6 cans of C for corn, and we have 4 bags of R rice. So that would be the total of each type. So either of those expressions would represent the total amount donated. Share your expression with classmates, and how are the expressions similar? How are they different? Well, again, we were either distinguishing by the type or just total of cans and total of bags. So how does adding or subtracting polynomials compare to adding or subtracting integers? Well, it's very similar, except now when we're dealing with polynomials, and we'll learn what that word means, we're dealing with algebraic expressions instead of just numbers and integers. So what is a polynomial? Okay, a polynomial, let's break down the terms. The roots of the word, poly means many, nomial sounds like name, so we're talking about a name of something. Okay, a monomial is a real number, a variable, or the product of a real number and one or more variables with whole number exponents. It's really just a term. Okay, a monomial is like a term, an algebraic term, so it can have a variable. For instance, 15x squared is one term. It's a monomial because there's just one term. Okay, so that's what a monomial is. And the degree of a monomial is the sum of the exponents of all of the variables. So for 15x squared, we only have one variable. The total exponent is 2, so this is a second degree monomial. Okay, mono meaning one term. For the second one, we see we have 2 variables. This is still one term because there's no addition or subtraction happening in between those variables. So this is one term lumped together. We have a coefficient and we have the variable term. And the total of the exponents is 5 plus 2 is 7. So this is a 7th degree monomial. Okay, it's of all of the variables in that term. A constant has no variable, right? We could think of it as x to the 0 because x to the 0 equals 1. So there is no technically a variable, but if we turn it into an x to the 0, then the term or the degree of that would be the 0th term, right? So the degree of a constant is 0 because it has 0 exponents. So then we have another type of polynomial called a binomial, bi meaning 2. So we're going to have 2 terms in our polynomial. So we have 5x cubed is one term and -4 is another term. When we're looking at the degree of a polynomial, which is more than one term, we look to the greatest degree of any term of the polynomial. Okay, and so usually you're going to put the highest exponent for the x first. We're going to order our variables in alphabetical order, and so the highest exponent, that's the degree of your polynomial. So here's a table to help you out. Again, these are a lot of new terms, a lot of new vocabulary words, but you can learn them. Just remember, polynomial is just algebraic expressions with more than one term, okay? So we've talked about a constant has a 0 degree, a monomial has a degree of 1, and this looks like y equals mx plus b, so this would be a linear degree. Okay, it has a special name when it has a degree of 1. Then we have this, now this would be called a trinomial, right? This is a trinomial because it has 3 terms. I'll highlight them. We have 1 term, 2 terms, and then +1 is another term, so there are 3 terms. This is a trinomial. The degree is the highest exponent, so x squared. The highest exponent is 2, so it's second degree. And it has a special name, it's called quadratic. You're going to see this a lot in topic 9 as well. Quadratic polynomials. And when you think about it, if we're squaring something, we're doing area. How many sides does a square have? It has 4. So there are ways that you can remember quadratic means a degree of 2. Here is a monomial. Okay, this is 1 term, so this is a monomial. And the degree is 3 because remember, we add up the total of all of the exponents on the variables. So 2 plus 1 is 3. And if I have 3 as an exponent, we're cubing something, so this is called a cubic polynomial. And then let's look at the last one. How many terms do we have? We have 1 term, +5x is a term, -2y is a term, and +6, our constant, is a term. So this is a polynomial, has 4 terms, so it's a 4th degree polynomial. There's no special name for this. Okay, 4th degree, 5th degree, etc. And it's 4th degree because if we look to the highest exponents of all of the variables, 2 plus 2 is 4. We're not adding any of the other terms, just the highest term. Okay, so why is this called a cubic binomial? Well, again, because our highest term is a degree 3, and that has a special name, cubic, and it's called a binomial because there are 2 terms. Polynomials are also named according to how many terms they have. We were just going over that, so I was kind of already doing that. This is a monomial, has 1 term. Binomial has 2 terms. Trinomial has 3 terms. And polynomial is anything more than 3, okay? So this one has 4. There's not a special name for that type of polynomial. Try it number 1. Let's name the polynomials based on the degree and number of terms. Okay, so part A, how many terms do we have? We have 1 term, so we know this is a monomial. Has 1 term. And what's the degree? So look at the exponents for all of the variables. Okay, there's an invisible 1 on the x, and there's an exponent of 2 on the variable y. 1 plus 2 is 3. So 3rd degree, or that special name is cubic. So this is a cubic monomial, 3rd degree. For the second polynomial, how many terms do we have? We have 6xy is a term, -3x is a term, +y is a term. So this is a trinomial. It has a special name, 3 terms. Now let's look at the exponents for the highest term. That's the first one. And there's an invisible 1 on the x, there's an invisible 1 on the y. Add them up. 1 plus 1 is 2. What's the special name when we have 2nd degree? Well, it's like x squared. We are we are squaring something, so this is called quadratic, trinomial, or 2nd degree. But the specific name is quadratic. Example 2, writing a polynomial in standard form. So this is important. You'll need to know how to write them in standard form. Just like we have standard form of a linear equation, ax plus by equals c, there's a certain order to writing them. When we're writing polynomials, you put them in order from highest exponent to lowest exponent, which would be your constant. Okay, and again, you're looking at the variable x first, like if there's more than one variable in a term, we're looking at the x. So we have this polynomial. You can see it's not in standard form because we are not starting with the highest exponent. So looking at the x, what's the highest exponent? Well, x to the fourth, so that term comes first. Then the next term would be 3, and we're just going in decreasing order of exponents. Then it would be 3x squared. Then the linear term, remember that's a positive 7x, and then the constant. So example 2, write each polynomial in standard form. So again, just highest exponent first. So we're going to put negative 3x cubed. Make sure you keep the term with the sign that is in front. Okay, so that whole term is 3x cubed. The next term is 6x squared, so that comes next. It's a positive. And then the constant will be last. For part B, again, now our only variable is y, so that's the one we're looking at. And that is a negative 8y squared. That is a positive 2y, and our constant is negative 3. So just be careful that you're keeping the sign in front of the term. How can we use the properties of operations to combine like terms and write the expression in standard form? Okay, so you can think of like terms as the same units. Okay, so we're looking for the same variable and the same number of exponents. So we can use algebra tiles first. So 4x is represented by 4x long tiles, rectangular tiles. 3x squared, that's going to be a square with an area of x squared. So then each side is x, right? This side is x, this side is x times x is x squared, and I have 3 of those. I have 2 more rectangular x's, have the same length, and then here's another x squared square. You can see I have 6 green tiles and I have 4 blue tiles. And then we have these singular units, 5 of those. So we can just combine all the tiles that are the same. How many x squareds do we have? We have 4x squareds. How many x's do we have? We have 6 x's. And then what's left is our constant, our 5 singular tiles. Okay, so like terms have the same variable and the same exponent. You cannot combine exponents. We can't say 4x plus 3x squared is 7x to the third. You can't combine them. They're not the same type of square. They're not the same unit. And then make sure that you write it in standard form with the highest exponent first. So we're going to put our x squared term first, then our linear term or our x term first, and then our constant last. Another way you can do it is highlight in different colors or underline differently the like terms. So I have an x term, I'm going to highlight the same x term, and I'm going to show you underlining. I have an x squared term, I'm going to give it 2 lines, and then I have another x term. Okay, and then I'll circle my constant. So just combine the ones that match up. Combine your x terms. 4x's plus 2x's is 6x's. Okay, and then combine your x squared terms. I have 3x squareds, and I add 1x squared, I get 4x squareds. And then I have my constant. Try it number 3, combine like terms, and of course write the expression in standard form. So I'm going to highlight the like terms. So I have an x squared term. Do I have any more x squareds? Yes, I do. I have a negative 1x squared. So remember, there's an invisible 1 right there. I have an x term, and it's a negative x term, and I have another x term. So I'm going to combine those. Okay, my x squareds, 4x squareds minus 1x squared. 4 minus 1 is 3x squared. Then I'm going to combine my linear terms, my x terms. Negative 3x's plus positive 3x's is just 0. I'll write it out, but I don't have to write that. So the simplified version would just be 3x squared. Okay, B, let's look at those terms again. So I'm just looking for the same exponent, same variable. I have 7y cubes, and I have another y cubed term. I have a linear term, a y term, and I have another y term, and then I have a constant. Let's combine the like terms. So starting with our highest exponent, let's start with the y cubes. 7y cubes plus 5y cubes is 12y cubes. And then I'm going to combine my y terms, negative 3y's plus negative 2y's. So I'm going to write that out. Negative 3y's plus negative 2y's. That is negative 5y's. And then I'll add my constant. I can't combine it with anything because I don't have any more constants. Example 4, how about adding polynomials? If I have two different polynomials, can I add them together? Well, it's the same as combining like terms. So here's just a quick review of adding integers, okay, and how we can regroup them or how we line up like terms. So if we're adding 123 plus 405, we line up the place values, right? We line up the ones, we line up the tens, and we line up the hundreds place, and then we add them together. We do the same thing with polynomials. We line up the like terms, just like we do with place value. So we put our longest polynomial on top, and then line up the like terms. Again, we have x squareds, those are like terms, so they're going to be lined up. Then our x terms, our linear terms, well, there's only one. And this time we do have more than one constant, so we can line those up and we will add them together. 1x squared plus 4x squared is 5x squared. 2x squared plus 0 is just 2x. Sorry, 2x's plus 0 is just 2x's. And then 3 plus 5 is 8. So just make sure you line up the like terms. That's easy, and adding vertically is very helpful. You could also add horizontally if you like. You can regroup them. So then just using the associative property, regroup all of your x squared terms together, regroup your linear terms together, and regroup your constants together. Just make sure you keep track of the signs in front of the term. Another thing that you can do is, like I was showing you before, just draw lines or connect or highlight the different terms. So I'm going to add up my x squareds, then my x term is by itself, and then I'm going to match up my constants. Be careful, that constant is a negative 3. So that's often where kids get tricked up, is just missing the signs in front of the term. All right, we're going to simplify or add these polynomials together, which is just combining like terms. So my first term I have is an x squared term. I don't have any other x squared terms, so that's just going to be by itself. I have an x term, and I have another x term, and then I have a constant. So this one I will show vertically. So let's line it up. 3x squared plus 2x. I'm going to leave space for a constant. Then I'm going to add, I do not have a x squared term. I do have a negative 1x term, and I have a constant. So I've lined up my place values. I've lined up my terms. So 0 plus 9 is 9. 2x's minus 1x is 1x, and then bring down my 3x squared because I'm adding nothing to it. For part B, I'm going to show you with arrows. So again, I've got my different terms. I have a x squared term. I don't have any others. I have two linear terms that I'm going to combine, and then I have two constants I'm going to combine. Okay, so my first one, I don't have anything else to add it to, so I'm just going to bring it down. Let's combine our linear terms. 5x's plus 3x's is 8x's. And now we're going to combine our constants. Negative 7 plus 7 is 0, so you wouldn't need to write it. Subtracting polynomials. Well, guess what? It's the same as adding. We just have to make sure we're adding negatives. Okay, so this one can get a little tricky if you are not careful of the signs. Remember, this is the opposite of everything in the parentheses. It's like there's an invisible negative 1 outside those parentheses that I would have to distribute. So I would have to distribute a negative 1 to every term inside the parentheses. Or you can think I'm doing the opposite of everything in the parentheses. So then it really becomes negative 3x squared and negative 5x. And what's the opposite of negative 8? Positive 8. So this one can get tricky if you forget to do the opposite of everything after that negative sign. If we're going to line it up vertically, you do the same thing as before. Match up the like terms, But now remember, we're subtracting. So 6x squared minus 3x is, x squared is 3x squareds. 3x's minus 5x's is negative 2x. Now this one's tricky. Negative 2 minus negative 8. Negative 2 minus negative 8. Just remember, the negative sign means do the opposite. So what's the opposite of negative 8? It is positive. So it would actually be negative 2 plus 8. So if you're really good at your number sense, you won't make these little mistakes. Okay, it's very important that you watch the signs. So then negative 2 plus 8 becomes positive 6. If you're going to subtract horizontally, do what I did up here, okay, where we did the opposite of everything in the parentheses. So then change the sign of everything and then match up your like terms. So match up all your x squared terms, okay, and they wrote that there. They regrouped them. Then you're going to match up and regroup your linear terms. Don't forget the signs in front of the term. Then you're going to match up and regroup your constants. Don't forget the negatives in front of the terms. So we're going to talk about a new definition, a new property called the closure property. And basically what it says is if you start with polynomials and then you do addition or subtraction and you end up with a polynomial, then that operation is closed. Okay, so if we have a polynomial to start with and we're adding another polynomial, if our answer is also a polynomial, like it stays the same type of expression, it's still a polynomial, we haven't whittled it down to one term, then this is called a closed operation. So addition and subtraction, if we start with polynomials, we're going to still get a polynomial, okay? So it is closed for addition and subtraction. Try it number 5, we're going to simplify and of course put it in standard form. So I'm going to write it vertically for the first one. So part A, we have 3x squared plus 4x plus 2. And then I'm subtracting. This is negative x comes under the linear term and a positive 4. Okay. 3x squared minus nothing is still going to be 3x squared. 4x is minus 1x. So I'm doing the opposite. What's the opposite of negative 1? That would be positive 1. So 4 plus 1 is going to be 5. And then 2 minus 4 is negative 2. Okay, part B, I'm going to do it horizontally and we're going to look at like terms. So first I'm just going to rewrite it and change the sign. This is the way that I prefer. So I know that negative sign means do the opposite of everything in the parentheses. So I'm going to rewrite it. Instead of positive 4x squared, it is negative 4x squared. Instead of positive 6, it's going to be negative 6. And now I can combine like terms. I only have one x squared term, so I'm going to bring that down first because that is my highest exponent. Then I'm going to look at my linear terms. I just have one, so I'm going to bring that down, and that's negative. And then I have my constants, negative 6 and negative 6. I'm going to bring them down and add them together, and I get negative 12. Application problem. An engineer is reviewing the layout of a solar farm. The solar farm shown has 4 small panels, 33 medium panels, and 32 large panels. So we have 3 different variables, right? Small, medium, and large. What is the total area of the farm's solar panel? You can see in this diagram the total area of the large solar panels, so large is represented by that. The total area of the medium solar panels is represented by that expression. And the total area of the small is represented by that expression. So those are our 3 polynomials. We just need to combine them to find the total area, right? So let's rewrite them. We're going to have 33x squared plus 384 x's. Then I'm going to combine the median, and I'm going to line up my terms as I'm writing this. 33x squared plus 272 x's. And then I'm going to line up my small panels. I have 4x squared and I have 24x's. I have no constants. That's fine. And now we're just going to add these all together. 33 plus 33 plus 4 is 70. X squared. 384x's plus 272x's plus 24x's is going to be 680x's. So that represents the total area. So a quick little typo. The large panels, it says 32, but then in the graph it says 33x squared. So either one, if we're going to say that's 33, then that's fine. Then our answer would be 70x squared. If we're going to change this expression and make it 32x squared plus 384x, then our answer would be 69x squared. So that was just a typo. I changed it to 33. Try it. Number 6. What expression models the difference between the total area of the large solar panels and the total area of the small solar panels? So again, I'm going to stick with what's in the diagram. So let's write the expression for the large solar panels. It was 33x squared plus 384x. And the small solar panels was 4x squared and 24x, and we're looking for the difference between them, so we're going to subtract those polynomials. 33x squared minus 4x squared is going to be 29x squared. 384x's minus 24 is going to be 360x's. So this is the difference between the large area and the small area. We made it to the concept summary for adding and subtracting polynomials. I hope you had as much fun as I did. Make sure you keep track of the signs in front of each term. That's going to be the key for not making silly mistakes when you are combining like terms. So watch those negatives. Remember, that means the opposite of everything inside the parentheses. If you have any questions, leave them in the comments. Make sure to like and subscribe and come back for lesson 2.